Hey guys, and today I'm going to show you how to calculate standard deviation and other measures of variancy. So in this math video, we're going to see what standard deviation really is and measures of variancy versus those of central tendency. All right, so standard deviation is a measure of the spread of your data or how spread out or clustered it is. For example, if you have a more spread out data, such as 1, 9, 25, 40, 99, 100, that's going to result in a higher standard deviation because there's more gaps within between the numbers. If it's more clustered, like 1, 4, 7, 11, 13, 12, 15, 16, 20, like that, that's going to be result in a lower standard deviation because there's a lower spread of the data. So these are your bell curves here. A higher standard deviation when there's a more wider spread of the values, and then a lower standard deviation when your values are all clustered, resulting in a more narrower bell curve. So you can also see this as how each value deviates from the mean. And to portray that, we have a nice chart right here to see what we mean by this different definition. So we have our bell curve here. This purple line is our mean. And then we're going to learn a new symbol, which is really called sigma. And sigma is the same thing as standard deviation. It's just a quicker way to write it and often used on your calculator and on other graphs. Okay, so when you see this symbol, you know that it means standard deviation. So then, if we have each of our data sets, we have our sigma 1. So how each value deviates from the mean. If these are sets of values, sigma is the standard deviation. Then from the mean to this first point would be known as sigma, or 1 standard deviation. From the mean to the second point, it'd be 2 times sigma because it's 2 times the number between the observations. And then for this third value, it's the mean times 3 sigma, or 3 times the standard deviation. And of course, this is the same thing for the negative side. All right. Now, this is also, we said, known as sigma. And what we also need to know is how these standard deviation is a measure of variancy, okay? But they are different. Standard deviation is known as, like I said, is known as sigma. But your variancy, which standard deviation is a measure of, your variancy is gonna be sigma squared. And for our purposes, all we need to know is that your variancy over here, it just leads to your standard deviation. Since that's not really clear, let me just put it in another color so you guys can see it well. There we go. So variation leads to standard deviation. Okay, variance is something that we use to get standard deviation. And now we're gonna find differences between ways that we can use standard deviation. And there's two differences or two formulas. Okay, so one is using it within a population, and another is using it within a sample size. But first, we need to know the differences between population and sample size. So, population is going to be all the observations within your whole category. So, all the observations within a category, okay? That's going to be your population. So, for example, if your population, if you're what you were trying to find out was how many students take honors in Neuqua Valley, your population would be Neuqua Valley if you're taking all the students that go there. But on the other hand, if you're looking at sample size, that's going to be only a few people out of your whole population. So your sample size would be only a group within the population. So if you were still saying how many people take honors, maybe you would only take the students with last names A to T. That would be a sample size because you're limiting your population and then using that to find the characteristics of your whole population. All right? So population is going to be population, we're gonna identify it as sigma, okay? It's a lowercase symbol of sigma. And then your sample size, we're just gonna find that using an S. Okay, so sigma's population, this fancy S is your sample size. And of course, they have two different formulas to find the standard deviation. Now, of course, you can use that on your calculator, but if you want to do it by hand, these are the formulas that you're gonna have to use. Okay, so for standard deviation for a whole population or all the observations within a category, that's gonna be a square root of your E, which is gonna be the sum of all your observations, X, which is one observation within your set, minus X with a dash above it, which means your mean. If you don't know what these symbols mean, then go watch my other video, which explains all the symbols that show up within your calculator, and divide that whole thing by n. And n is the total number of observations you have. And then we also want to square our numerator. All right, so that's the formula for standard deviation. The formula for population looks pretty similar, but it does have one tiny difference. And one sec, let me erase the denominator because that is in fact what is different. So your sample size, that's going to be still square root of all the sum of all your numbers times a given observation minus the mean divided by, it's still going to be n, but it's going to be n minus 1. And why do we do n minus 1? Well, of course, you know, a sample size is only a group within the population and therefore has to be smaller than the actual population, which means that there can also be sets of data just due to random chance. So that means they're not going to be all statistically significant. So there's a lower chance that they will. So to account for that difference, we need to subtract 1 from the total numbers because one of those values might be just due to random chance or to account for any outliers that exist. Because a sample size, we are taking a risk of assuming the characteristics for the entire population by just taking a group. So, this is really it for population and sample size. And this is all you need to know for today's lesson. But we also don't have to forget how measures of variancy differ from what we learned in last lesson, which is going to be central tendency. So measures of variance are going to be how the data is spread out, how they vary, while central tendency are going to be three those three important values that we find every day, the three M's, your mean, median, and mode. Okay, so that's really it for your standard deviation and measures of variancy. And next video, we will discover how to calculate standard deviation and just a basic review of what we have learned thus far. And maybe even do a couple of practice problems. So guys, thanks for watching and I hope you learned something new.